Let's practice writing and evaluating some algebraic expressions together. Now, to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. For questions 1 through 6, let's go ahead and take each sentence that we see, rewrite it as an algebraic expression instead. Whenever we see a number, we're going to go ahead and use the variable y or the letter y to represent that. And then we're going to go ahead and evaluate that algebraic expression in two specific scenarios when y is equal to -3 and when y is equal to 1/2. So we'll evaluate the expression given two different hypothetical y values. All right, so for number 1, we have 5 more than a number. So let's see, we have a number that's going to be our unknown, and that's going to be y. If it's 5 more than that, that means we're going to be adding 5 onto something. So it's going to be plus 5, and we're adding 5 onto y. That's the unknown number, right? So that's going to be our expression. Now that we know the expression, let's go ahead and evaluate it given the specific value of y equals -3. And so if we go ahead and substitute this in, we're going to see that we're going to have this -3 plus 5. And if we go ahead and just evaluate, there's just one step here, so it's nothing too crazy. But -3 plus 5 here is just going to be equal to +2. All right, now what if y is equal to 1/2? Well, if y is equal to 1/2, then we'll substitute in 1/2 in for y. We'll say it's going to be 1/2 plus this 5. If we add 1/2 and 5 together, let's see what that's going to be. We can actually just keep this as a mixed number. That should be a lot easier to do. So we can just say this is going to be 5 and 1/2. All right, let's check out number 2. For number 2, we have a number less than -5. So let's see, we have this a number right in the beginning. It's going to be that thing or that number less than -5. So we're going to start with -5, and we're going to go ahead and take away what variable we're using. I think we're using y here, right? So I'm going to take away y from that. So it's going to be a number less than -5. That number is y, or some unknown, and it's going to be less than -5, so we're taking it away from it. All right, so we have our algebraic expression. Now let's go ahead and evaluate it when y is equal to -3 and when y is equal to 1/2. So in the first scenario, we're going to have this -5. Let's go ahead and take away this -3. So go ahead and keep that in parentheses here. All right, and then if we go ahead and just evaluate this expression, again, it's just going to be one step here. -5 take away a -3 is really just -5 plus 3, and that's going to equal -2. Now, what if y is equal to 1/2? Well, we would have this -5 and we would take away this 1/2 from it, right? Now, if you go ahead and just evaluate what is -5 take away 1/2, well, if you take away 1/2, you're just going to add a -1/2. It's the same thing. So this is going to be -5 and 1/2. This would be the value of the expression if y was equal to 1/2. For number 3, we have 7 less than a number. So a number is going to be y. It's going to be 7 less than it. So the expression is going to be, we are going to start with y, and we're having 7 less than it. So we're going to take away 7 from whatever that is going to be. All right, so we have our expression. Let's go ahead and now evaluate it for these different scenarios. So here we have y is -3. Substituting a -3 in, we're going to have -3 minus 7. And again, just like all the other ones so far, we really just have one step. So -3 minus 7 is equivalent to -3 plus -7, which is going to be -10. Now, what if y is 1/2? Well, if y is 1/2, we're going to have 1/2 substituted in for y. Let's go ahead and take away 7 from that. So we have 1/2 minus 7. That's going to go into the negatives, right? So 1/2 minus 7, that should be -6.5. So I'm going to write -6 and 1/2. That would be the value of the expression if y was equal to 1/2. Let's see, for number 4, we're going to go ahead and find the quotient of -6 and a number. So let's see, we have a number over here. Now, what does quotient mean? Quotient means we're dividing, right? So we can go ahead and rewrite this as the quotient of -6 and a number. So we can either write -6 divided by that number, which is going to be y, or you could also rewrite it as a fraction, right? We can say it's going to be -6 over this y. That would also be representing the quotient there. Alrighty, so here we have our two different hypothetical values for y, and so let's go ahead and evaluate. So this first scenario, we're going to take this -6, let's divide that by -3. There's only one step here, which is kind of nice. So -6 divided by -3, that's just going to equal +2. All right, so that's pretty straightforward. In the second scenario here, we have y is 1/2. So I'm going to actually just rewrite this one from left to right. It might be just a little bit easier. We're going to have this -6, and we're going to divide this by 1/2. Now keep in mind that if we're going to go ahead and evaluate this thing, when we divide fractions, we can rewrite it as a multiplication problem, right? So we can say this is going to be -6 over 1 multiplied by this 2 over 1 if we multiply by the reciprocal. We're going to see that nothing's really going to cross cancel here, so if we multiply out, this is just going to equal -12. In number 5, we have 5 more than a number. So this is actually identical to number 1. So what you can actually just do is just say that it's the same as number 1, or you can just go ahead and copy and paste just like that, and we can move on to number 6. So that one's kind of a freebie. All right, what about for number 6? For number 6, it says the product of -4 and a number. So let's see here. We have a number at the end, and then we're going to be taking the product of -4 and that. So that's just going to be the expression -4 multiplied by whatever the variable is, which is going to be y. All right, so let's go ahead and evaluate this if y is -3. So we're going to have this -4, and let's multiply that by -3. Again, nice and straightforward. There's only one step, so -4 times -3, that's just going to be equal to +12. All right. In the second scenario here, we have this -4 multiplied by this +1/2. Now, if we go ahead and just take half of -4, half of -4 is just going to be -2, right? So I'm not going to write down any extra work here, just because half of an even number is a little bit easier to do. So that'll be the value of this expression. All right. For 7 and 8, let's try some with some compound verbal expressions here, so more than one operation, right? So in this case, just keep in mind that when we see a number, we're going to use the variable x instead, and then we're just going to evaluate it one time when x is equal to -2. All right, so we have 4 more then, which means we're going to be adding 4 onto something. And then what are we adding 4 onto? Well, it's going to be the product of 5 and a number. So this a number here is going to be our unknown. That's going to be x here. So how do we show 4 more then? We're adding 4 onto the product of this 5 and a number. So 5 and a number is going to be 5 multiplied by x, which is just going to be 5x. And 4 more than that means we're going to be adding 4 on afterwards. So this would be our expression. All right, so let's go ahead and let x equal -2. If that's the case, we're going to have 5 multiplied by this -2. So I'm going to say 5 multiplied by and substitute in that -2 here. And let's go ahead and add 4 on afterwards. Okay, so following the order of operations, let's just multiply first. So 5 times -2, that's going to be -10. So we have -10 plus 4. Just one operation left, but -10 plus 4, that's just going to be equal to -6. So if x was equal to -2, then this expression would be equal to -6. Number 8, let's go ahead and see we have 5 less than. 5 less than means we're going to be taking away 5 from something. So what are we taking 5 away from? It's going to be the quotient of a number and -2. So quotient means we are dividing. What are we dividing? 2 things. It's going to be a number and -2. So let's go ahead and see if we can go ahead and write this. So we have a number and -2. The quotient of that is just going to be, I think, x divided by -2, or x over -2, and it's 5 less than whatever that is, so we're going to take away 5 afterwards. Now let's let x equal -2 and go ahead and evaluate this thing. So if x is -2, we can substitute that into the numerator of this fraction, or this division problem. So it's going to be -2 divided by -2, and then -5. And following the order of operations here, -2 divided by -2 is going to be +1, so we're looking at 1 minus 5. And then if you take 1 and take away 5 from it, 1 minus 5 is just going to be -4. So this would be the value of the expression if x was equal to -2. All right, let's switch gears a little bit. In questions 9 through 11, we're going to go ahead and write an algebraic expression so that we can represent each of these situations that we are given. Then we're going to enter some follow-up questions to make sure we're showing some detailed and logical thought process along the way. All right, so let's see here. In number 9, we have a rectangle. This rectangle has a length that is 3 more than twice whatever the width is going to be. We know W is going to represent the width of this rectangle. And so if you just want to imagine a rectangle for a moment, we can call maybe this side over here as W for the width, and the length is going to be 3 more than twice the width. So let's just see, if the length is going to be this other dimension over here, it's got to be 3 more than twice the width, so that's going to be 2W plus 3. Right? That's 3 more than twice whatever the width is going to be. So now we can see our 2 dimensions of this rectangle. It says write and simplify an algebraic expression that represents the perimeter. So let's see, the perimeter would just be 2 of the widths, right, plus 2 of the lengths. So we could go ahead and say something along the lines of this. This would be an expression that would tell us the perimeter of this rectangle. And then if we just went ahead and simplify this a little bit here, we can say that 2 times W is really just 2W, right? So we can say this is going to be equal to 2W. And then if we go ahead and distribute here this 2 to both of these terms over here, we can see that we'll have 2 times 2W, which is just going to be 4W. and then 2 times 3 is going to be 6. Okay, now let's go ahead and just combine these two like terms here. So 2w plus 4w, that's going to be 6w. So we have 6w plus 6. So in terms of what would represent the perimeter of this rectangle, this would be the expression right over here. It would just be 6w plus 6, and that would be, this whole thing would be labeled with the units because we don't know what it's going to be. So while this is the original expression we could write to represent the perimeter, this would be the simplified version of that perimeter. All right, now for the area here, we can go ahead and say the area is going to be length times width, right? So we know the two dimensions. Here's the length and here's the width. So we go ahead and say that it's going to be w multiplied by 2w plus 3, right? So this would tell us the area of this particular rectangle. Now, if you want to go ahead and simplify this thing, we can also go ahead and distribute the w on the outside using the distributive property. Now, if we multiply w times 2w, we can go ahead and use the commutative property and associative property and rearrange it a little bit. But the 2 can stay in front, and the w times w can be w squared. And then w times 3 is the same thing as 3 times w by the commutative property, so that's going to be just 3w. So in terms of an expression that represents the area here, we can say it's going to be 2w squared plus 3w. And this would be square units. You could say units squared. All right, so while this is just the length times the width here, we can go ahead and just use distributor property, and this would also represent the area of this rectangle. All right, in part C, we're going to go ahead and find the perimeter if w is equal to 6. So this is the perimeter expression we got earlier, so let's go ahead and just use that. If we go ahead and copy this down, the perimeter is going to be equal to 6w plus 6. We know w, though, is going to be, I'm going to use the same color as I did earlier for the values here. So I'm going to go ahead and say that's going to be 6 times 6. We're going to substitute that in, then plus 6. Following the order of operations here, 6 times 6 goes first. That's going to be 36. So we can say this is going to be 36 plus 6 units. And then 36 plus 6, that's going to be 42. So the perimeter here is going to be 42. So we can say the perimeter is 42. We can just say u if you would like. For this next question here, it says determine the area of the rectangle if w is equal to positive 2. So for the area, we're going to use our area expression. So we can either use this or this. Let's go ahead and use our more simplified version here. So the area is going to be equal to, let's see, it's 2 times, and it's w squared. So we know w in this case is going to be 2. So it's going to be 2 raised to the second power plus 3 multiplied by this 2 here. Okay, now if we go ahead and start cleaning this up a little bit, following the order of operations here, 2 to the second power is just going to be 4. So we can say this is going to be equal to, let's go ahead and say, write it down here, it's 2 multiplied by 4 plus 3 multiplied by the 2. And then we have some order of operations, so we have 2 multiplication problems. I'm just going to do them both left to right here. So 2 times 4 is going to be 8, and then 3 times 2 is going to be 6. So if they're both the same operation, we can just do them left to right. And then finally, we have this 8 plus 6, and that's going to be 14 here. So you can say if we knew that w is equal to 2, then the area of this rectangle would be 14 square units, or 14 units squared. This right here would be our solution. All right, let's try another one. For number 10, this one's very similar. We have another rectangle here, so let's go ahead and sketch one out. All right, so it doesn't matter which one you really label as what, but we have a rectangle that has a width that's going to be 3 less than quadruple the length, and t is going to represent the length here. So I'm going to go ahead and say that this side is t. It really doesn't matter again. The other side is going to be 3 less than quadruple whatever that length is. So quadruple means we're multiplying it by 4. So I think we're going to have 4t, and it's 3 less than that, so it's going to be 4t minus 3. All right, so let's go ahead and see if we can write an expression for the perimeter now that we kind of labeled our 2 dimensions here. So the perimeter is going to be, we're going to have, 2 of these t, so 2 times t, plus we have 2 of these 4t minus 3s. Okay, so that's going to take care of all 4 sides. Now if we go ahead and just multiply 2 times t, that's just going to be 2t. And then if we go ahead and just distribute this 2 to say there's 2 of those and there's 2 of these, 2 times 4t, that's going to be 8t. And then 2 of these negative 3s is going to be negative 6. Now we go ahead and just combine some like terms of 2t plus 8t. That's going to be 10t. So we're looking at 10t minus 6 here. So what can we write for the most simplified version for representing the perimeter of this rectangle? We can say it's going to be 10t minus 6. and it's going to be units. We don't know what the units are, so we just write units by default. All right, cool. Moving on, let's see if we can write an expression to represent the area. So we know the length and the width already. The length, we're calling it's going to be t, and the width we know is the other dimension. We said it's going to be what, 4t minus 3. All right, so that's going to be the length times the width. That's going to be the area. All right. Now we can also simplify this a little bit by just distributing this t on the outside here. So t times 4t is going to be 4t squared, and then t times negative 3 is going to be negative 3t. Okay, so this right here would be the expression for the area. So we can go ahead and just say this would be 4t to the second power minus 3t, and this would be square units, or units squared. This right here would be a simplified expression that would represent the area of this rectangle if we knew what t was equal to. All right, so for this next part, we're going to go ahead and find the perimeter if t is equal to 4. So we know a hypothetical value for t. Let's go ahead and use the perimeter expression, which is right over here. All right, so let's see. The perimeter is going to be equal to 10 multiplied by 4 in this case, right? And then we're going to go ahead and add on or take away rather 6 afterwards. And then so if we go ahead and follow the order of operations here, 10 times 4 is going to be 40. So we're looking at 40 minus 6, right? And then 40 minus 6 is pretty straightforward, just one step here. That's going to be 34. All right, so we're going to say the perimeter here is going to be 34 units if we know that t is equal to positive 4. All right, and for this last question, that's kind of following up with what we were just talking about. Now we're going to go ahead and find the area, specifically when t is equal to 8. We have our expression earlier from here that tells us the area of this rectangle. So the area here, we can go ahead and just plug in. It's going to be 4 multiplied by, and we're saying t is 8, so we're raising 8 to the second power. And then we're also going to be taking away 3 multiplied by that 8 again. All right, so if we evaluate this expression, we'll get the area of this rectangle. So following the order of operations, the exponent or the power will go first. So 8 squared is going to be 64. So we have 4 multiplied by 64 minus 3 multiplied by 8. And then following some order of operations here, we have 2 multiplication problems. So let's just kind of go left to right here. So if we have 4 first multiplied, actually I'll just highlight both of them. So we have 4 times 64 and 3 times 8. The one on the left would go first, and then the one on the right would go in the next step. So I'm just going to do them both at once. So we get 256 for this first one, and then we'll get 24 for the second product here. Okay, so if we go ahead and multiply and then we go ahead and subtract afterwards, we should end up with 232. So the area of this rectangle, if t is equal to 8, would be 232 units squared here. This would be the area of this rectangle if t was equal to 8. All right, so in number 11, we have a rectangle. We know the length is going to be represented by m and the width is going to be represented by n. So we're going to go ahead and write an algebraic expression that represents the perimeter of this rectangle using m and n, as well as the area of this rectangle. So for the perimeter, we can just go ahead and say it's going to be 2 times m plus 2 times n. This right here would tell us the perimeter of this rectangle. And then for the area of the rectangle, we just have to go ahead and multiply the length and width together. So we can just write something like m times n, or mn. So this right here would represent the perimeter of this rectangle, and this expression over here represent the area of the rectangle. All right, now let's take a look at part B. In part B, this says that if we have the length and the width are both doubled, write an algebraic expression that represents the perimeter and area of this rectangle. So what if we go ahead and double each of these dimensions? Well, let's see. For the perimeter, if we go ahead and find that one, well, keep in mind, if m gets doubled, that would just be 2m, right? So we would have the 2 of these 2m's, right? 2m is double of 1m, plus we'd also have 2 of these 2n's, right? So keep in mind here that we did have m before, but now it's 2m, and we did have n before, and now it's 2n, just because we doubled each of them. Now we can go ahead and instead of multiplying 2m and by 2 later, we can just kind of turn the order around a little bit and say it's going to be 2 times 2, which is going to be 4. So we can say this is going to be 4m plus, using a similar thinking here, 2 times 2 is going to be 4. This is going to be 4n over here. So this expression right over here would represent the new perimeter of this rectangle if both the length and the width were doubled. Now, what about the area? Well, if we now have a new length of 2m and we have a new width of 2n, if if we go to multiply these together, we can go ahead and use the commutative and associative property and rearrange a little bit, but the area of this rectangle would be 4, because you can multiply that 2 times 2 together first, and then if we multiply m times n together, it's going to be mn. So we have over here the expression for the perimeter, which is 4m plus 4n, and here we have the area, which is going to be 4 times m times n. All right, in part C, we have another extension question here. So in this particular case, what if the length and the width are both tripled instead? Let's go ahead and write an algebraic expression that represents the perimeter and the area of the rectangle, given that this has happened. So let's see, we had m, then we had 2m when we doubled it, and we tripled it, it's gonna be 3m. So for the perimeter here, we're gonna have 2 of these 3m's, just because we tripled the length here. We're also gonna have 2 of these 3n's because the width was also tripled. So 2 times 3 is 6, 2 times 3 is 6. So for the perimeter, our expression here would just be 6m plus 6n. Now what about the area? The area has 3m for the length, and the width is going to be 3n. And again, we can just go ahead and use the commutative and associative property and just rearrange the multiplication here. So 3 times 3 is going to be 9, so that's going to be our coefficient. And then m times n is just mn. So this expression here tells us the perimeter of this rectangle, and this expression tells us the area of this rectangle. All right, let's check out one final part to this question. So it says, define a hypothetical value for m and n, evaluate the perimeter and the area from parts A, B, and C. Then afterwards, let's go ahead and explain how doubling and tripling the dimensions affects the perimeter and the area. All right, so hypothetically, I'm just going to go ahead and define that m is going to be 4 and n is going to be 3. All right, so let's go ahead and now evaluate given these particular values of the variables. So if we go ahead and do that for the part A, this was where we didn't double anything or triple anything. So if we go ahead and find the perimeter here is going to be 2 times 4, and it's also going to be plus 2 times 3. So 2 times 4 is going to be 8, and 2 times 3 is going to be 6. So we're going to have 8 plus 6, and that's going to be 14. So we're going to have 14 units for the perimeter here. Now, what about the area? The area here, if we plug in 4 and 3 for m and m, that's going to be 4 times 3. 4 times 3 is going to be 12, so we're going to have 12 units squared here. So it looks like we're going to have these two different expressions to represent what we have. So the perimeter here is going to be 14, but the area here is going to be 12 units squared, and this is if m is 4 and n is 3. All right, for part B, this is where we doubled each of those dimensions. So we're going to use this expression for the perimeter and this expression for the area. So for the perimeter here, let's see, that is going to be 4 multiplied by 4, plus we're going to have here 4 multiplied by 3. Now, 4 times 4 is going to be 16, and 4 times 3 is going to be 12. So we're going to say 16 plus 12, that's going to be 28 units. Okay, now what about the area? Well, the area we said was going to be 4mn, so 4 times m is going to be 4, and n is going to be 3. So we do 4 times 4, that's going to be 16 times 3, and 16 times 3 is going to be 48 units squared. So when we went ahead and doubled the length and the width, we can see here that we have a new perimeter here of 28, and we have a new area of 48 units squared. So before we kind of come up with any conclusions, let's go ahead and do the same thing for part C now and evaluate the area and perimeter. All right, so for part C, let's go ahead and see here, the perimeter is going to be, what do we say that expression was for the perimeter? Oh, that's right, we said it was going to be this 6m plus 6n, and the area is going to be 9mn. So let's go ahead and say we have, for the perimeter, 6 multiplied by 4, plus we have 6 multiplied by 3. So 6 times 4 is going to be 24, and 6 times 3 is going to be 18. So 24 plus 18 is going to be 42. So we're looking at 42 units for the perimeter. Now for the area, let's go ahead and say we said it was 9mn, so it's going to be 9 times 4 times 3. Now 9 times 4 is going to be 36, and 36 multiplied by 3, I believe, is going to be 108. So it's 108 units squared here. All right, so here is our perimeter, and here is our area. Now, how can we go ahead and look at all these together and come up with a pattern or a kind of understanding why these numbers are the way they are? Because now we're going to go ahead and see if we can say, how does doubling and tripling the dimensions affect the perimeter and area? So here's the perimeter when we didn't do anything to the dimensions, just kept them the same. Here's the perimeter when we doubled the dimensions, and here's the perimeter when we tripled the dimensions. So when we doubled the dimensions, notice that the perimeter also doubled, and then we doubled the dimensions, notice how over here, the perimeter did triple. 14 times 3 is 42. So notice how when we doubled and tripled the dimensions, the perimeter also kind of followed along and doubled as well. Now, what about the areas? Well, we had an area of 12, and then we had an area of 48, then we had an area of 108. So this is kind of interesting here because even though we doubled the dimensions, the areas did not double. When you double the dimensions, notice how this actually 4 times larger of an area when we double the dimensions. And then when we triple the dimensions, you can see here that it's actually 12 times 9 is 108. So it's actually 9 times greater of an area when you triple the dimensions. Okay, so why is this happening? Well, keep in mind perimeter is a one-dimensional measurement. So whatever multiplying the dimensions by whatever number, the perimeter is also going to increase by that same ratio. However, when you're dealing with area, it's a two-dimensional measurement. So when you made the length and the width both 2 times bigger, this 4 is really 2 times 2, so it doubled in both dimensions, right, in 2 dimensions. Kind of similar with this 9. 9 is really 3 times 3, or it tripled in both dimensions, so kind of makes sense that it's going to be 9 times bigger here. So let's go ahead and kind of put those a little bit more eloquently in some words. And so here is what we're going to say. So we know that length and width of rectangles are both one-dimensional. They're just measuring how long something is, right? But we also know that perimeter is also one-dimensional because it's really just a bunch of lengths and widths added together. So I think it's kind of safe to say here, and hopefully it makes sense, that when you go ahead and double or triple these lengths or widths or whatever you're talking about here, then the perimeter is also going to do the same thing just because everything is in the same dimension of just one-dimensional. Now, however, area is two-dimensional. So when we go ahead and double or triple the length and width, and again, we're doubling both the length and the width, or we're tripling both the length and the width, and then you go ahead and multiply those together, the area of this rectangle is going to become 4 times and 9 times greater than it used to be. And this should hopefully make sense just because we're multiplying by 2 twice for the length and the width. So it makes sense that 2 times 2 is 4. And hopefully it makes sense we're multiplying by 9 here just because we're multiplying by 3 twice. So 3 times 3 is going to be 9. All right, so there you have a few different practice problems dealing with some algebraic expressions, just kind of coming up with some and kind of understanding the relationship, especially applied to some geometric concepts as well. Hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.